Today let's learn about basics of decimals. The topics that would be covered are definition of a decimal, comparing decimals, and converting fractions to decimals. First let's learn what a decimal is. Just like we use fractions to represent parts of a whole, decimals also can be used to represent smaller parts of the whole. For example, in this fraction, 4 is the whole number and 3 by 5 is the fraction. Similarly, in this decimal, 4 is the whole number part and 0.6 is the decimal part. The word deci means 10. So in case of decimals, we divide the whole into 10 equal parts. 6 out of these 10 parts would be 0.6 and 2 out of these 10 parts will be 0.2. Now let's consider the decimal 1.42. Here the decimal part 0.42 has 2 numbers. So that means our whole has to be divided into 100 equal parts and not 10. So to represent 0.42, we would be considering 42 out of the 100 parts. And in case we have 3 decimal places, we would be dividing the whole into 1000 equal parts. And the list goes on. Now let's move on to comparing decimals. Before getting started, let us check out some facts that we already know. In these examples, we can see that any number can be preceded by one or more zeros and the value doesn't change. But when you consider the decimal part, you can add any number of zeros behind the numeric value and the value of the number is the same. Now, in these examples, if you enter zeros behind the numeric value in the whole number part, the values change. Similarly, if you insert zeros before the numeric value in the decimal part, the value of the number changes completely. Now let us start comparing with some examples. 0.4 and 0.7. We can see clearly that 0.4 is less than 0.7. Next we'll consider with 2 decimal places, 0.42 and 0.26. Here 0.42 is larger than 0.26. Now let's move on to a different example, 0.4 and 0.04. Now when we compare 2 decimals, we have to make sure that the number of decimal places in both the decimals has to be the same. But 0.4 here has only one decimal place and 0.04 has 2 decimal places. So we need to convert 0.4 to have 2 decimal places, and that is simply done by adding a 0 at the end of the decimal. And as we already discussed, the value is not altered. Now it becomes easier to compare 0.40 and 0.04. Clearly, 0.40 is larger than 0.04. Let us check out few more examples. 0.567 and 0.63. We can see that one number has 2 decimal places and the other has 3. So to make them both have equal decimal places, we convert 0.63 to 0.630. So 0.567 is lesser than 0.630. Next, 0.098 and 0.978. Now consider all the 3 digits after the decimal point. So 0.098 is lesser than 0.978. Next we'll compare 0.15 and 0.095. As soon as we look at this question, we feel that 0.095 is larger. But you need to think clearly here. there are 2 decimal places in one number and 3 in another. So to make them both equal, we add a 0 at the end of 0.15. Now we compare 0.150 to 0.095. So 0.150 is larger than 0.095. Finally, let's learn how to convert fractions to decimals. There are 2 methods involved. In our first method, we will convert the denominator of our fraction into either 10, 100, 1000, etc. For example, 3 by 5. When we multiply both the numerator and the denominator by 2, we get 6 by 10, and that has a denominator of 10. So the decimal would be 0.6. Next example, 8 by 25. Now when we multiply both the numerator and denominator by 4, we get 32 by 100. That gives us the decimal of 0.32. The next method involves long division. Here we divide the numerator by the denominator. So let's attempt to divide 5 by 8. Since 5 is smaller than 8, we put a decimal point after 5 and add some zeros to continue our division. But now the important point to remember is you need to place a decimal point on the quotient as well. After placing the decimal point on the quotient, you can consider the dividend as a normal number and start dividing. So first, considering 50, we have 8 times 6 is 48 and the remainder is 2. So we bring down one more 0 to make it 20. Now 8 times 2 is 16, which gives us the remainder of 4. Bring down another 0 and now we have 8 times 5 is 40, which gives a remainder of 0, and hence the division ends here. So 5 by 8 can be written in decimal form as 0.625. Now let's check another example. 8 by 3. So we divide 8 by 3. 3 times 2 is 6, which gives us a remainder of 2. Now we need to place a decimal point in the dividend. So 8 becomes 8.0. And since we have placed a decimal point on the dividend, we also need to place a decimal point on the quotient. Then bring down the 0 from the dividend to get 20. 3 times 6 is 18, which gives us a remainder of 2. Bring down a 0 again to get 20. So 3 times 6 again is 18, which gives us a remainder of 2 again. Now you can see that the pattern is going to continue. So 8 divided by 3 is going to be 2.6666 and so on. This kind of a decimal is called as non-terminating decimal. And to represent such a decimal, we put a line on top of the number that gets repeated as shown here. Another example, 9 by 11 gives us the decimal 0.818181 and so on. So the repeating numbers are 81 and is represented as shown here. Finally, let's take another large fraction, 129 by 55. After doing long division, we can find the answer to be 2.3454545 and so on. So the numerals 45 are repeating here. So you place a line only above 45 and not the 3 as shown here. With that, we have come to the end of the video. Hope you have understood some basic concepts of decimals. If you would like me to make a video on some specific topic, do let me know in the comment section below. Any feedback and suggestions are also welcome. If you found this video useful, give it a like and subscribe to my channel. Thanks for watching.